So we are live, and I already no, I would be lying. I didn't forget what we did. I would be lying. Um, Something that I am kind of worried is that LSP didn't kick in, which is concerning. Um, oh no, it did. Wait, what the crap? Okay, it did. So I added back the company mode that I was using, so now we can hover onto stuff to see the types.
Nice.
I don't want that. I don't. I just want the hover. I don't want everything else. So I don't know how I'm gonna get on going because probably I'm gonna have to read the source code of the company mode.
Wait,
But okay.
what do you mean on everything else?
Do you see that we have the error message on the right?
Yeah,
I don't want that.
but also doesn't
I want the
doesn't do much
previous.
harm, right?
No, I want the previous LSP that I was using before. That has like that has everything in the mini buffer down here. But I want the hover capability of company mode. But company mode is huge, so I don't know how I'm going to do that. But that's a problem for the later me, I guess. So let's go with that. So we were doing some types, right? Which made the episode of the previous session perfect. The attack of the sun types. Uh, and
Let's say so.
I remember that we discussed about doing things vertically, right? Instead of like we're gonna group things together vertically speaking and stuff. But I don't remember how exactly we were planning to do that. So let's do the following. So let's reread what we did, okay? So this is the block of code that we did last time, okay? So now we are,
Really?
yeah, just this,
No way.
just that. I
Wait,
don't
do you
think
have
we did.
another auxiliary function that we did?
No, I think. Oh no, we did this as well. We did this as well.
Okay.
So this is a more generic version of the literal stuff, but for all the possible patterns.
Okay.
And so we did that, and then we spent most of our time talking how we would be doing the transposing stuff.
Yeah, and it's probably a way that we will change right now.
No, really?
Yeah.
Okay, so let's go then.
Uh,
So you have this
so,
list here, right?
mhm.
This is the list of constructors, which has a name of the constructor and the types that it is, a list of types there. And this is the list of pattern, guard, and expression. Okay. So what do we need to do, Nathan?
I don't know.
Okay, so I will read what we already done. So the first thing that we do is see if all the possible patterns in this list here, if all of them obey the rule of each pattern type, according to the type that the algebraic one that we have here, right? So the each pattern, we are mapping each pattern using the each pattern time partially applied using a map. This function will give us the correlationship between the pattern and the type, right? So in the case of the T algebraic, we're gonna do this, which is basically a zip width, checking if we, and then it's also checking if we have
Yeah, we can totally abstract this. Like,
yeah,
just think about this function of can it match or not, right?
yeah, and then we check if all of them are okay, and if they are, we do this. Some of them aren't. The best error message at the moment is this one. Podium
What is
flawed and
that?
following.
What is? Wait. What is that, dude?
I
Like,
have absolutely no idea why I wrote that. For now, it's gonna be this. Okay. Then, but let's go to the then. The then block. If we we are okay, right? So the patterns and the types are totally okay. Then we're picking the list of constructors, which has a name and a list of the types. And for each one of them, we're picking the name of the constructor and filtering the patterns that has that name of the constructor that matches. Okay? Is that okay? Should we be
Yeah.
doing that?
I don't know about that, but I get what you are saying.
Okay, so you don't know about that. Okay. This returns this. Oh, I remember what we got wrong last time. I totally remember. The problem is that you can't pick this list of lists and transpose them because maybe you're gonna mix the constructors, right? So maybe you have a left and a right and a left in the list of
It's not a
patterns.
maybe, right?
Wait, what?
Not sure if it's a maybe.
No, it is a maybe because it is a corner case in which all the lefts are grouped together.
Uh, dude.
Let me give you an example. So you have this, then I don't know, a tuple, and then you have that. Then you're gonna have a right with the string, right? Another left. For each one of those patterns, oh well, actually it's the opposite. For each name of the constructor, so let's suppose that we are doing for the left, right? We're doing for the left. So we are searching for left here. Left is written here. Then we are filtering from the list of patterns and guards and whatever. We are checking if the constructor name is the same as in the pattern, and if it is, we're gonna filter that. So we're gonna be ending with we're gonna have this, right? We're gonna have filter. This is the part that is filtered out.
No. Do the following. Let as it was before, like the right. And this is the initial state of like the branches, right?
Yeah, this is the
Now
initial
do
state of this list here.
yeah. Now do after that like another like text indicating the result, right? The list that we get as result. So we have all the steps, right?
Yeah, that.
Yeah, do like a list, right? Like what we actually get because
Yeah, so it's gonna
it's
be
harder to.
something. And I'm assuming
Okay.
that eventually the right will be also filtered there.
Okay.
So it's gonna be like that.
And is that the whole result?
Yeah.
Okay.
Okay.
Now we go for the next step, right?
Okay. There's a problem. There's a problem. What is the problem? The problem. Oh man, I see now. Okay, I think I know how to use the transpose correctly. Because what we are doing now is that we are picking this list, which is this list right here, and we are applying transpose. What will that do? Right. So let's pick again the example of the
Like the
transpose.
first left with the first right, the second left with the second right, like makes no sense.
This first one with this first one, right?
Yeah.
Let's suppose that you have something else here as well, so we can have matching ones.
So do you agree that's always resulting in like a wrong thing?
No, transposing here, it does. It is wrong.
Okay.
So, but that's the thing. Now that we have this list here, we should map this bigger list, and we should map the transpose to that. What you think?
I don't know what you mean. Can you
Can we?
repeat that?
Do you agree that we want to apply transpose to the internal list that we have here? Because imagine that this is a list, right? So this is a list in which we have only one type, which is the tuple type. Right?
This is a list.
No,
Like
no.
the tuple is between the name left and the list.
The name
A
left.
list of patterns.
The list of patterns. I don't know if I understand what you
Uh,
mean, but
yeah. So, like, those are patterns, right?
yeah,
Like a list of patterns.
yeah,
So the pattern of the sum stuff, it's the label and a list of patterns, right?
yeah.
So you see your left there, that's
Hmm.
a tuple of the string left and the list of patterns.
Yeah,
They being like the pattern of int 1 and the pattern of int 2. So the tuple is on the wrong place.
the tuple is in the wrong place.
Yeah, you can just like delete the tuple from there, and the tuple is between the left name and the list.
Well, I mean the way that we are modeling that as a data type.
Yeah.
Yeah, I understand.
So those
I think
are the
it's
ones
harder. I
that we
think it's
want
harder
to
to
transfer.
read in that way, but it makes sense. I was not thinking. I didn't want to add this auto amount of syntax, but okay.
Yeah, that's actually easy, right? So you can transform this list of patterns with left in just something like extracting all those lists, right? The internal ones, and then you want to transpose them.
There's a problem though. But it's not really a problem, but we need to pay attention to it. We need to carry because you need to remember this list, which is the result of all of this. This list also has the guard and the expression, and we need to keep those on track, right? I remember that we need to make those still being bounded together.
Okay, wait. Let there for a second.
Okay.
Oh, let me see. Like different left, we have different like maybe expressions and expressions. That's okay. So when we are, that's very, very, very interesting. Yeah, I know that we care about the guard and I know how to solve it, but do you know if we care about the expression? Because I think we don't, right?
We already discussed about that, and we agreed that we don't.
Ah, so fuck that. So the maybe expression, when we are like condensing the things together, right? It's simple. Where the maybe expression is a just, it will enter on the final result. And where it's not, it will not. Right? Because what are we doing? We want to extract those internal lists, to then transpose them, so we can analyze them like in the way that we can call the check exhaustiveness, right?
Yeah.
But the thing is, if one of those has a guard, it doesn't even need to be there. Because if you think about any pattern that has a guard, it's completely disconsidered, right? Regarding if that will add something or not for the final goal or progressing towards being
Wait, wait,
satisfied,
wait,
right?
wait. I think I got lost. So let's do the following. I agree with you in a sense that everything that has a guard that is not nothing, that thing is already done. Like we already can discard the entire thing saying that the thing is not satisfied. I understand
No,
that.
no, 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 wait. Uh, yeah, we know that you're not satisfied, but more than that, it doesn't contribute at all to the progress of satisfying the thing, right? Can you see that? For example, if I use the pattern 1 in an int, it will not satisfy it, right?
Yeah.
But do you agree that it can help the progress to satisfy it, even though in this case it will never, but it's progressing?
I don't know what you mean about contribute to the progress. That's kind of weird.
I'm storing that to the ones that were already matched. So my list of matched, it's getting bigger. I'm progressing, right?
Are we doing that with integers?
Of course we are. We need that not to match the when we are satisfied because it would never happen, like with ints at least. But
Oh
we
yeah,
are
we are.
keeping track just for the error case of repeated patterns, right?
Yeah, the unreachable key. No. Yeah, the unreachable case. The unreachable case. We check if the pattern already in the our saved list, and if it
But
is,
you got what I mean with the guard? Like, it doesn't help with any progress regarding satisfying the thing.
yeah, we don't save that.
So yeah, we don't save that.
Yeah. Okay, so let's do the following. Try to divide and conquer. Let's try to divide which functions do we need. I think that the first function that we need is a function that picks a list of patterns and
Wait.
return
Because
to us the
like,
list of lists.
wait, Lemos. Like that is something that might be a bit true, right? Because like, even though we can discuss that and implement that and stuff, and would be good for us to like have a better understanding, like discuss this about the guard and those stuff.
Yeah.
But I feel that what we are doing like right now, it will not lead nowhere. So what about we take a step back and see if that's like feasible at all? Because maybe you are implementing something that, well, it was doomed from the first place, right?
Okay, I think that's very hard because you're gonna have to keep track of the steps until we reach until we reach the conclusion that it's actually not worth to pursue it, right?
Actually, it really doesn't look that hard thinking here.
No, maybe for you. I'm talking about myself.
No, but if the steps are like, how can I say, like feel simple but maybe abstract, I'm sure you will just go with it, like through it also.
Yeah,
Uh,
I will repeat. If I don't like this process of having to keep the burden in my memory of what we already have done. I don't like
oh,
that. I
the
think
wording
it's
that you said is like this code that we are doing right now.
no, not this code.
Okay.
From this onwards. So for example, we're gonna have to imagine that we have the functionality, we have the capability of going to each pattern in this list here, right? In each pattern in here, and we want to extract the list in the case of the sum type, right? So all of
Yeah,
these
wait, maybe you
details
are
are
going
building up.
to, yeah, maybe you are going too specific. So that's the abstract part. So let me try to describe better what we maybe could do.
Okay.
Uh, I proposed that solution, right? Of when we are dealing with some types, we extract the internal patterns, right? Like beforehand to do some check, and then we go back to the other checks, right?
Yeah.
So it's good so far?
Yeah, so you're suggesting to go to each sum type and extract the list of
No,
patterns,
no,
right?
no, 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 no. I'm just like telling the story that, okay, I proposed that, and that's the solution that we're trying to implement, right?
Yeah.
So yeah, so I'm feeling that this might be doomed from the start. We would just think about if that it's doomed from the start. And the only thing we need to think about is the following. Just doing that out of order, uh, how can I say, causes, how can I say that?
What do you mean by out of order? I think that's the first question.
Okay, so the what is the ideal scenario, right? The perfect scenario. We have a type and we have the branches, right?
Yeah.
We fold the branches and it's done. You agree?
We fold the branches and it's done.
Yeah, because you literally go line by line of the branches, checking everything at the same time. You do literally the following. You check if the pattern is valid,
Yeah.
then given that bind, you check if the guard is valid with those binds. Then you check if the body is valid, like also taking in consideration if they are agreeing with each other, and that's just like a piece of the accumulator, right? Check that. So you see, it's just a fucking fold, right?
I don't know which fold you're talking about. I agree with the procedure. Go on.
Yeah, but so everything is happening line by line, right? So as soon as we get an error, we get it, right? Like we got it.
Oh, you mean considering all the branches and all the guards and all the patterns?
No, no, no. I have the branches as a list, right?
Yeah,
Like,
you're gonna
and
if you're talking about folding that list of branches, that I agree.
so yeah. So doing that, as soon as we get an error, we got it, right? Like
Mhm.
that's it.
Yeah.
But with our approach, I fear that that might mask some error that could happen before and goes undetected or something like that. Like the out of order could cause some problem, right? And I'm not sure. Maybe it doesn't.
What can you tell me? What are you seeing here that can potentially make the things out of order?
No, no. Okay, so better for me to explain what I mean by out of order, right?
Yeah, that would be great as well.
Uh, so we are getting the branches.
Mhm.
Then we are going through a procedure collecting those things that we are doing, right?
Yeah.
But you see there are like other stuffs that we are not checking in the meanwhile.
Yeah, we're not checking other things, I agree.
For
Not that that
example,
matters because this is only checking for exhaustiveness. We need to remember that we are this function has a purpose. So,
no, 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 sure, sure. Like, because there are two cases. The first case is you have two problems, right? And like the first problem occurs on line one, the other on the line two, and you report the second one first, right? So that's not a huge problem, right? You are still reporting correctly. You are just in a weird order, right?
okay, fair.
So that's a case that is not a problem. It's just weird.
Yeah, it's just weird.
But what I'm saying is, what if the out of order that I used to explain causes that we are maybe, uh, how can I say, doing in a way that an error can happen and we will not be able to catch that error.
An error can happen, but you're not able to catch that.
Because the out of order way we do it. And I will try to expand on it. So the first thing, what I mean by out of order, uh, we are collecting all the things there regarding the internal patterns and checking that.
Yeah.
But we are not doing some other stuff, right, at the same time. Like we are not checking the guard, the body, what I think might not cause a problem.
Yeah, no, yeah, we chose definitely the most inefficient way of doing this.
Yeah, it's not regarding fusion,
No,
but
it is regarding efficiency
no,
because it is
also,
because
but it's not the problem that I'm talking about.
okay, okay, that's fair. Okay, so but you agree that we have a lot of computations that you're gonna do two, maybe even three times because we're gonna have to traverse this list a second time to check if the guards are okay.
Yeah. So my fear, it's not performance, it's not
Yeah.
a
Go.
strange report. It's literally like having a wrong
Mhm.
result. So, for example, when we are doing those of checking the inner ones, we are not checking, for example, if I don't know, uh, you got the unreachable case. Maybe that's
You're not
one.
checking.
We are not checking for that kind of stuff, are we?
No,
Not
not
really. Like,
here.
could that be a problem? I don't know. Let's see something else that we are not checking, like right there. Supposing that's the first thing we do, and it might cause a problem.
Yeah, no, yeah,
Uh,
but that's the thing. That's the thing. I think I totally understand your point now because that example of not checking for unreachability, in the case that here we are definitely not doing that. We are doing in other places, but not there. I think that's a fair point, what you're talking about, like trying to do a step back and see the greater picture to see if you can. But that's the problem, right? Because we don't know the correct solution for this, right? And I think that if we stop producing a dumb solution, a very bad solution, and then trying to combat the drawbacks later, we're going to spend a lot of time just thinking. And I think that
Yeah,
can take a lot of time trying to find the diamond in the middle of the thing.
yeah. Uh, but there is a thing. We don't know like the a solution like made, right? Like we don't know the final result will be for solution.
Yeah, we don't know that.
But we do know something. We know that if we go the fold step by step, there is no concerns about that at all. Also solves the thing about maybe performance, I wouldn't say for sure, and the part regarding reporting things right.
Yeah, no, I totally agree with you that the fact that we are picking a choice, the fact that we know that we already are aware that, oh, we're not going to be able to do enrichability, we're not going to be able to do X and Y and Z, that's great. We should document all of that, right? But my problem is that I think it's okay to make a dumb solution if we try to keep note on what are we exchanging with this approach, right? For instance, the unreachability is definitely worth a comment, right? The fact that we are not checking because, and I think that's fair that we are not checking because this is hard. I think it's okay to do the hard things in a numb way first, and then later we can do a step back and make it better, especially after we know, okay, it's done. You can make it work. The golden case works. What about you have an unreachable branch with the left, for instance? That is when we're gonna say, okay, we need to change that now. But we were already aware that we would have to do that. You see?
Yeah, we can try to go with that and see if we find some like fatal flaw, right?
Yeah, if we find a fatal flaw, that is when we stop, right? And then we reconsider the entire thing from scratch. Because I, that's totally possible, by the way, right? That's totally possible. Um, unreachability is not being checked with the current approach. Um, yeah, so although I agree with you that we are not like but if for instance if it's easy, like if it was not easy but a little bit easier to identify that okay it's not a fold, it is X, then okay, forget about the fold and let's go with X. But my understanding is that we don't know X.
Wait, what do you mean? Isn't the opposite? Like the
No,
fold is the one we are not doing, right?
no, I was using the fold as an example of the
Oh,
what you're
okay.
talking about, like, oh, let's do it in a
One way
fold.
or the other, right?
Yeah, exactly. But we don't know the other way because if we knew, we would be using it the better way. Um, and we are just trying to make something work and then going from there. Uh, I think actually I need to put like a disclaimer is that this philosophy only applies if the thing that you are doing will not like blow the entire project, okay? So if you are making a feature that has the potential of breaking breaking the entire thing from like nobody can use it and then you're done and you're
Yeah,
screwed.
no, pattern match is just pattern match. Doesn't.
Exactly. But I want to put a disclaimer is that if you have a feature like that, do not do the like don't necessarily follow what I'm saying. So because
Yeah, that
that's
is something else, Amos. What you are doing is not just what you are saying of the dumb way. It's something else. It's something else. In this sense of approach of out of order, approach of the fold. The fold we know cannot be wrong regarding like the order of the fold cannot cause a problem. The out of order might. Right? That's not only choosing the dumb way. That's also like making a bet, right? Because the dumb way, I would think like, sure, like it's we know as much as the other like bit more spark way. We know that they have the same chances of breaking or not, but in this case, it's not quite right. One is very uncertain. we are doing the bad because,
Yeah,
well, it's easier to do it, like in some sense.
yeah. Let's
Right?
just make sure that we are using the same terminology. So you're talking about out of order in the sense that we are doing a filter and that is changing the order of the branch. Is that what you're talking about?
No.
Okay, so
What I mean is we are doing some steps to gather the internal patterns
yeah,
and use that to check some stuff, right?
yeah.
But when you do that, go through the list, then you have to do another, like doing something else, right? So it's not line by line.
Yeah, no, but it is the filter then. The filter is changing the order of the list of patterns.
No, no, it's not. Yeah, it's not that, man.
Wait, okay, so let me try to rephrase it. Do you agree that this list has the order, like the order of all the branches as
No,
the
no,
using?
it's not about that list or the order that the list gets. It's about the order in which we check stuff. That's the thing that goes out of order.
Yeah, wait, but now I am confused again. Wouldn't the fold be using this list?
Yes,
So the order of the fold is following the order of this.
yes.
And doing a filter on it, we are changing it.
No, no, we are not.
Oh, then I don't understand what you're saying. Yeah, I'm sorry.
Yeah, it's like the following. For example, I have a list with the three things right there. What are those? Like the guard, the no, the pattern, the guard, and the body, right?
Yeah,
So let's suppose we go line by line, checking one, two, three. Next line, one, two, three, right?
yeah,
You complete that. You agree that that's going line by line, like left to the right, checking the errors.
yeah.
But that's not what we are doing, right?
No, that's not what we are doing. I agree with
We are
that.
going through all the list, checking kind of the one, then we go to the list again, checking like some other stuff. That's what I'm calling out of order.
Oh, you're calling the entire process of checking it.
Yeah, we have multiple process, and we are doing in a batch out of order way, right? And the fold would be like one by one, top down, left to
Yeah,
right.
but there's a difference, right? There's difference in philosophy. If you use the line by line approach, you need to do all like you need to make a strategy. I'm not saying that's the a worst way, but I'm just saying it's different. You need to make a strategy that will check everything,
Yeah,
right?
you need to be concerned with all at the same time, right?
Exactly. And here we are just laser focused on exhaustiveness.
Yeah, that's the aspect that makes this like arguably dumb way easier in a sense to reason about, right?
Yeah, of course, because we don't have to care about other stuff right now.
Exactly.
We are laser focused on one single aspect. Of course,
So
it
we
will
have
be
another
completely
example of that.
inefficient. It will be completely inefficient. And that's fair, that's fine.
Again,
Later on,
not talking about inefficient here.
no, but I am. I'm adding the list of bad things that this approach picks, right? The first thing is the fact that we are not certain that we can do this. Is exactly what you said. We are more certain that doing line by line would be like safer in a sense.
Yeah, exactly
We
same.
don't know if like doing divide and conquer works. We are assuming it does. We are doing that assumption. And and the only disadvantage is performance, right? Because we need to traverse the same initial content multiple times to check the specific criteria. But that's the benefit. It's a specific criteria per time, right? So we are only focusing on that. And now I think I understand what you're saying. The out of order aspect is a bet. It is. It is a bet.
So yeah, we can do a quick comparison. For example, take a look on where you are calling the check exhaustiveness.
Check. It is in the type check e pattern
Use your
list.
editor to. So see, this is like the it is out of order and in the dumb way, right? And has the performance drawback and has the benefit of is easy to reason about because we are first doing the exhaustiveness and then we check if all the bodies have the same type, right?
Yeah, exactly.
So yeah, but this time it's not a bad because it's easy to see that
Yeah.
it doesn't go wrong.
No, assuming that check exhaustiveness and all and checking if the bodies, at least my understanding is that they can be separated. This process can be separated. They don't affect each other. The only
So,
drawback is performance because, like you said,
no, no,
for me
no.
it's clear that it's
And
okay.
and the report is also in a weird order, right? Because, for example, suppose the second branch is returning the wrong type.
No, but that's
Uh,
the thing. If we want the one criteria to matter, quote unquote, matter more in the sense of throwing an error, we just do this.
no, no, but like it doesn't matter if you do one or the other. Like in both cases, the report will be weird for the user. But what
That
I
I
mean
don't know.
is, the performance. You say like it's worse. I tend to agree, but I wouldn't say for sure. Like I don't know, a bunch of stuff.
It
The
is possible
report
that in
error.
Haskell it's not worse actually, but okay, go.
So the report error, it's not wrong, but it's weird for the user. But we know that is not wrong. Like in
I don't know
the
about
sense
you.
of
I don't know what you're calling weird in this sense because do you agree that it's better
I
to
can
have
explain that.
it's better to have an error message about different types of bodies first than having the problems with exhaustiveness? Do you agree?
No,
No, you prefer having the error of exhaustiveness first.
it depends.
It
Uh,
depends. That's
yes.
that's very interesting.
So, for example, for me, the ideal way of reporting would be top down, left to right. You go line by line, checking everything from the left to the right. You first check the pattern, right? And if the pattern is valid for the type, if it is getting something like unreachable, right? Then you check the guard, then you check the body, then you go to the second line and repeat. So for me, that would be the best report, right?
I see. I think I see. Oh
But
well.
yeah, let's keep going.
Anyway, so do you agree that everybody's agreeing that we are making a bet, that we can make the thing out of order and it will be fine, and we are also
Yes.
agreeing that we are doing the dumb way first because that's all we have on our hands right now, and it's probably bad and it's probably not correct, or at least that it has a better counterpart implementation. But we are not going to care about that at the moment. We just want to make it work and see and have a better understanding that's what we need to do.
Yes.
Yeah,
So
okay.
let's solve the transpose, right?
Yeah, so the first thing is, so now that going back to the implementation, I would like to have to list the process. So let's type it in English first. So what we have this list here. Should we have this list? This list of lists?
I guess we do.
Okay, so do you also agree that all the lists will have the same constructor name and they will be grouped with
Oh,
that?
wait. Oh, okay, okay. Can you repeat that part?
Yeah. So the the outer list will contain a list, and the inner list will have all the sum types because this match sum type will always return. Only allow this to be a sum type. I can even go there to demonstrate that. So if you have
Okay.
if you have a sum type and a label is equal, that's okay. If you're not, you're false. So that means, although we don't have that certainty via the types, we only know because we are humans. These patterns are always sum types.
Yeah.
Okay. Then the other thing is that each inner list, right? So the listing is an
I
element of the other one.
agree that we generate the format on line 7. Line 7
Yes,
dot.
yes,
I
exactly.
do agree with that.
So okay, so do you agree now that we need to extract for each one of those? We need to extract the list that they contain in the second member of the tuple.
Yeah, yeah. Now I remember a problem. of like when you asked, how did you ask? Like, is it okay to have this list? And then you pointed to matched some types, right?
Yeah.
And I said that yes, but maybe it's not. Maybe it's
Great.
not.
Great.
Not because of the transpose problem. Everything that we were thinking for the transpose problem, I guess it was okay. But what is the problem? Because we also need to like synchronize that with some types that are inside constructor. And I don't think we can do that later.
Wait,
I
I don't
think we
know.
need
I
to,
don't understand what you said. Can you repeat?
yeah. So we will end up with the name left, like after all the transpose and shit, we will end up with left. Wait a second. Yeah, we will end up with like everything together, right? How can I say that?
Yeah,
Like
we're
you
gonna
have
have.
the left, you
Mhm.
have left, and you have two spots, right?
Yeah.
You will end up with all the first spots of left, everything grouped, all the second ones of left, everything grouped. Let's suppose we succeed in doing that, right?
Okay.
But we would need to know, uh, okay, but what is the type that should go into those patterns?
No, but we know that.
ah,
We have it in here.
yeah, I know we have constructors, but then you have to match them there, right? You need to do a way to bind those together to, well, zip them, right?
No, but that we can. We just f map. We just need to f map this result of the filter.
Oh, that's the thing. So if we should get this match some types, that's the part I say maybe we don't because we cannot do this afterwards like
No, yeah,
in
we
a
can't do that afterwards.
in a okay way, right? So I
Well,
guess it needs to
actually,
be there inside.
wait. Actually,
Maybe you can
isn't that this?
because
I am crazy. Am I going crazy? Isn't that something like, oops, something like TS this? What is
I
the
don't
type of
know.
that? Yeah, that.
Yeah, wait a second, right? It might be that I will
No,
read
I
in
don't think it's that because I think the pattern, the type should be in the tuple.
well, I will read in a few seconds.
Okay.
But how can I say? Oh, okay. Maybe you can do the thing after, but you need to keep track of indexes.
No, but that's exactly what you said last time, right? And then my immediate reaction to that was that I don't think we need because we already have the types on hand here.
No, no. Again, if we want to do afterwards, like
Yeah, but that
after we
sucks.
have
Yeah, but that
matched,
sucks.
yeah, exactly. So let's go inside, right, and see what you did there.
Okay.
So let's start from the beginning, like from the map, right?
Okay.
We are mapping the constructors.
Which each thing on that list has a name of the constructor and the list of types.
Perfect. And then what we are doing is filtering, right?
Yes.
We are filtering the list of patterns,
The
right?
list of patterns, yeah, which is this.
We are grouping together
All the
the
ones
list
that has
of
the same
patterns.
constructor name.
Yes, exactly. That has the same constructor name.
Yeah. Then for we are also grabbing the types that we know are certain for this constructor, and then we are zipping that with
Yeah,
this, and then we get this.
yeah. Give me a second there because I think that's terribly wrong. I guess. Uh,
I don't think that's terribly long. That's just hard to read.
no, not regarding the code on what it does. Uh, like that is already like the result of this filter is already all the filters together, right?
Yeah.
So
Wait. What do you mean by all the filters together? The result of the filter is a tuple.
like
Oh, it's a list of triplets. Sorry.
no, let me repeat. The result of this filter there is
Yeah.
all the patterns
Yes.
grouped by the constructor name,
Yes.
right?
Yes. Yes. Yes.
Okay. So, okay, I have a list of left constructors, right?
Yeah.
And inside each of them has the list of patterns.
Yes.
Okay? And I'm grouping each different instance of the left with a different type that the constructor left carries.
Yes.
That doesn't make sense.
Yes. I think it's wrong indeed then. What we need to do is to inject the type into the other list, right?
Yeah.
Okay,
Yes,
okay.
exactly.
Yeah, so I do have a way to of making that happen. So let's go and make a function for that.
No, 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 no. Wait. Because maybe we just need to return a tuple of the types in that list of left lemmas.
Maybe we just need to return a list of types.
No, no, no. A tuple
Tuple.
of of TS and the result of this filter.
I think I think that we don't need to do that, but for the sake of readability,
Oh,
it's
you want to put
necessary.
it inside, right?
Yeah,
I see.
for the sake of readability, I would totally agree.
And Grugs, right?
Okay, so now we have this. So this is
Uh,
a list of tuples in which we have a list of types in the first memory of the tuple, and we have a list of patterns in the second
do
memory.
you know? Do you know why, dude? Because oh, that's perfect, Lemos. Now you can zip, dude. Now you can fucking zip. Because take a look. First of all, look at this type, dude.
The type of
Look
this.
at look at this fucking type, dude. Come on. What are we doing with our life?
We
It's
are
not
making a
something.
language. We are making a language. That's
It's
it.
not something ultra hard to understand. It's just
A lot.
I don't massive, right? It's a lot. But okay. So look at the thing that we can do.
Mhm.
Ah, all the things that we were talking about, right? Of doing transpose and blah 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 and blah blah blah. We can still do it to the second half of the thing, and the result of that list, I think we can just zip with those types
Okay, I have a
because.
proposal.
Mm,
What about type checking first and then transposing later?
what do you mean by type checking?
We need to make sure
Oh, if the
that,
patterns match, right?
yeah.
Oh yeah, that would be good, dude.
So what about doing the type checking of the patterns first, and then if we are okay, I would actually argue that this is better for error messages as well. Um, because we would tell the type error first in this case. So what do you think about that?
I don't need, I think we cannot even do anything if we don't type check first.
No, you
Well,
can. You can
quote
transpose.
unquote type check.
No, you can transpose without
No,
type
no,
checking.
yeah, you can transpose, but
It's just like useless
you
if the
cannot do
type is wrong.
yeah. But what I mean is, you cannot do the check of exhaustiveness and stuff if you don't type check first. I
Oh,
guess.
okay, yeah, that I didn't think about. But let's do it then. So this will be a list of tuples. This would be a list of tuples. So we're gonna map that, right? So this is gonna be something, and we're
No,
gonna
no,
map
wait, Lamos,
that.
Lamos, Lamos. I think we already did that, dude.
Did I?
Like, I think you're like, what was the other place that? Okay, you. What are the places in which you use the? Oh, shit. What is the auxiliary function that we have for matching to see if a pattern and the type match?
It is the is pattern type here.
Is pattern type. It's okay. Where are we using this?
We are using that to see if
Use the editor. We want to be sure.
no, no, we are only using it once. Is pattern type. Oops. We are using it. No, we are not using it. Oh no, it calls itself. Okay, so that's why. That's why. So you only use it once, which is in here. Oh no, you're using two places. Sorry, this shoe. This shoe.
Okay, I think we don't care about the infinite result, so go to the next one.
Yeah, this.
Infinite. Oh, okay, that's okay. What we are. Dude, so that's already this for Muslims. Like, that is checking recursively, I guess. Like, if
Wait.
the internal patterns are valid for the internal types.
Oops. This. Okay, so you're talking that we are already doing that.
Yeah, like there, exactly there.
I think you're correct. I do believe you're correct. So we do not need to
We gladly don't need to check that shit.
Okay, so it's already this if is doing wonders then. It's already doing that. So what do we need to do?
Now it comes the part of the transpose, right?
No, 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 but then we don't need the types then.
Huh? No,
Do you
no, wait.
what is the purpose of having the
Oh,
types?
no, we do. Uh, so, because you need the type to call the checkx.deepness, right?
Do I?
Of course.
Oh, I do. Yeah, okay. Okay, so I guess we can map this with zip. Is that? What is this again? This is a list of tuples. The crap. Okay, so let's make the dumb way first. So it's gonna be, I don't know,
Wait, what do you want to achieve?
T. Um, I want to do what you said before. I want to pick the lists and zip them. So what's the type of that?
But wait, but before you need to do all the transpose stuff. Only afterwards you can zip the types with
Oh. Okay, so
the
let's go
right side.
again with that. So you want to transpose this list of tuples?
Yeah, it's complicated, right?
Yeah, because I remember that to use transpose you need to have two lists. Isn't that right? Yeah. Yeah,
No, no,
here.
yeah, but go to the example that we had there on the comments, like down there. No,
Trans.
not of transpose of the or yeah there. So yeah, there when we need to extract the lists and do the transpose, right?
Okay, so let's do that.
Yeah.
So we're gonna do a map, right? We're gonna do a map, and we're gonna make a function called um, extract
Wait,
patterns.
isn't the map already on the second part of a tuple?
I believe so. So we can just do like that, you mean? Like this and then
Would be
like this.
great.
Yeah, that would be great. So let's do that function because that's very easy. So extract patterns. So
Wait, what?
this will,
Extract patterns?
yeah, this will pick a pattern and return for us a list of patterns. And I believe that this is that. Like this,
Wait,
and then extract
not sure if you're
patterns.
talking about this.
And then we can do this, but instead of that, we're gonna do this. And instead of this, we're gonna do
Oh, let
that.
me find like the end result that we need.
Extract patterns. Everything else, we're gonna return an empty list. Although that should never ever happen. So, so. Oh no, it's not enough. Holy moly, dude.
Take a look on what I typed.
Holy freaking moly. Wait, take a look on what you typed. Pattern. Wait, we want a type in the list of patterns, is that correct?
That's the final result that we want. It's a list of a tuple with
Yeah.
a type and its patterns. The
Okay.
type, it's like the
Okay,
type
okay,
of the
okay.
internal thing, and the patterns are the vertical ones, right?
Okay, so I am guessing that this function needs to be that entire thing. That. Yep. Then then these extract patterns. Uh, um This will be a list. Then
You mean like this is the part you are mapping, right? So why you are returning the list of patterns instead of the like real thing that we want?
wait a sec.
Oh wait.
Uh,
Oh, okay, because I see, yeah. Because you haven't zipped it yet, right?
yeah. So this will be p some type nothing ps. Oops, like that. Um, it will be something along these lines, I'm guessing. Yeah, that. Then you're gonna return to me the PS. I'm gonna return to me the PS. What if you are not um, uh, what if you are not that? I'm returning a list of lists. List of lists. List of lists. Why am I returning a list of lists in this case? Hmm. Okay, I think I see. So we actually gonna map that down there. Okay. So this is gonna be like that. Then, let me think. Let me think. This will be a triplet, right? And then we're just gonna reuse this like that. Yeah, this will work. Then down here, we're gonna make a lambda that will pick the two things. It will pick the types, and you to pick the triplets, and that will return another tuple, but now it will map. Oops, it will map this to that triplets. Yeah.
Yeah, no, that's wrong because you have a list of types there, right?
No, wait. Do you
You
agree that
want
the second member of the tuple is also a list, right?
wait.
The
The
second
what?
member, the second member of this guy, the tuple is another list.
Yeah.
Okay. So what I am doing here is that I am picking the. Oh, I think I know what is this thing suggesting. Suggesting to do this. Yeah. Yeah, like that. Yeah. Okay. So what's the type? Couldn't match. What's the type of this? Yeah, this is three lists one inside the other. That's a lot of things. Okay, but now it is okay. Okay, so this is what we have.
Dude, like, don't you? Oh wait, you're just. Yeah, I don't know what you're doing.
Okay, let me try to explain it. So, we have a tuple in which the the
Okay, types
first,
and triplets, right?
yeah, we have a list of triplets in the second member. Okay?
Okay.
Do you agree? Okay, so what we need
Yes.
to do is to pick that list, this list here, and transform that to another list of patterns. Is that okay?
Let me see.
Because this is p some type. Imagine that it is written p some type. In each p some type, we have a label and another
Wait,
list.
wait a second, dude.
Oh, it is saying to do second. That's why it is complaining. Okay, that's smart.
That is something weird. Let me see what it
No, it
is.
is weird because in your representation down there, we have only one list of patterns. But the end result here is a list of patterns. That's the problem.
Wait. There is something off. I don't think that's good. Let me see. So every element, what we have there concretely, we have this list of types that is like what the left was carrying, right? Yeah. So yeah, okay, we have that. And then we have the patterns there of the group lefts. Okay.
Yeah.
So let me see.
Okay, so
I
let
will
me try to
need.
give you an example to help you. So
Wait,
this
wait,
is
wait, just a second. I need to
okay. Go.
really think about something.
Okay, go.
Ah, like we have the group lefts, but what we need to return from that is a list of patterns,
And that's what we
and
have.
then we zip. Yeah.
Why do you think I'm gonna make this thing better? Second.
Well, the types looks correct, but yeah, I need to see the implementation.
Map.
The first question is, are you using transpose? If not, it's wrong.
Okay, we are still not using transpose, but calm down.
Oh, okay, that's just like to make the types check, right? It's not the...
No, we are making. Dude, this is very confusing. Let's go line by line.
Yeah, can you like separate it in another window there? Like, I'm going to see this and the implementation of the extract patterns at the same time.
Okay, that's totally doable. So down here. Okay, so extract patterns. That is there. Oop, here. And this
So
is
let
where.
me just see in which context you are using that, right?
Okay.
You are... Well, can I just say that you are mapping the second element
Yeah.
of that list of tuples with the extract patterns?
Yeah.
Okay, so that's enough. So uh, guide me through the implementation, right?
Okay, so we have the list of tuples, and the second member of that thing is also a list, right? So we are grabbing the second member and we are mapping the extract patterns function there. And what that function does, it picks a triplet, which is a pattern and a guard and a branch, and it returns for us a list of patterns. In this case, it will be focused on getting the list of patterns inside the psum type. And everything else, it will return an empty list. That empty else, actually this shouldn't be empty list. This should be error. This should never happen. Yeah, that should be this. Because we know for a fact, because of this filter and this match sum type, that we don't have in the list of patterns that. We don't have anything aside from psum types.
Yeah.
But we don't have that certainty using the types, so the type system. So that is what we are doing right now, right? And now, my
Wait,
understanding.
wait, 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 wait. Oh, shit, you have two maps.
Yes.
Oh, so yeah, that's a problem, I guess.
No, no, no. I don't think that's a problem because the transposal happened in this one. After doing this map in the second, we're gonna pick the second again and do a transpose on that. So actually, it's I guess transpose. I guess it's just this. Yeah.
Okay.
So what we are
Okay.
doing, we are grabbing that list, this list here. Oops.
Wait, let me get the implementation of extracted patterns out of the way. We get the triplet,
Yeah.
right? And it has a sum with a name and its patterns, right?
Yeah.
We just get the internal patterns.
Yeah.
Okay.
Yeah. I'm gonna do
Now
that.
let me see. We get, we are mapping the second element of it, and we are mapping with a map. Uh, So let me see. Yeah, hover that thing that you are hovering.
This?
No,
What?
I I guess
This?
matched some types.
Okay.
Yes. So let me see. I'm matching. No, I'm mapping
Yeah.
this. Huh. Wait, what the fuck? I'm mapping. Oh, okay. Yeah, indeed, I'm mapping uh, the right side of
Yeah.
the thing, with another list, the two
Yeah.
maps there. So let me see. Indeed, what I want is separate them, like in each row from every left I got, and then transposing the. Yeah, I think that's correct, dude. Yeah.
I'm
Do
glad
you
you
need
agree.
a name for anything? We don't, right? Oh,
Wait, can you
we
remember why
do.
do
We do need a name.
wait, wait, the name for what?
Because all of those things are like the following. How do we know when we can add the left case into the matched patterns? We know when all the internal ones are satisfied. But how can we say that we satisfy the left case, right? We don't have the label anywhere.
I am confused. Let me just ask you another a simpler question. Why do we still need a list of types again?
Why do we still need a list of types? We
Yeah,
are going to zip them together.
no, yeah, but why do we need it for what? For which purpose?
To call the check exhaustiveness.
Oh, that's why. Because we need to call the function recursively afterwards.
Yeah.
Okay.
So we check if the inner patterns are satisfied, right?
Yeah. Another question
But
for you, which is that is easier than what you were about to say, is that don't we need the guard in the expression to be also to call check exhaustiveness?
not expression, not at all. Oh, yeah, okay. Okay, sorry. You need to call it, right? Because we did that way, but you shouldn't need, right?
No, you mean ideally.
Yeah, like ideally, right? But yeah, we do need to make like it compile, right?
Okay,
Uh,
but that's just a like we're gonna have to. I'm gonna change the
yeah.
type signature of this thing, and then we don't have to tackle that problem again. But now go to the problem that you're talking about. Why do we need the name? That's what I'm confusing.
We also asked about the guard, right? We don't
Yeah.
need the guard. We will pass everything as none, not as none, as nothing, right?
No, we
Yeah,
wait. What do you mean by passing everything as?
because to call the check exhaustiveness, the list it receives has a guard, right?
Yeah, well, but what about the branch?
Look, the branch we will get or you will eliminate, like, right?
Oh, eliminate from the function at all.
Well, yeah, like
Okay, okay.
because we don't really need.
No,
But
we don't
well,
need.
you can also pass a dummy value, right?
Yeah, we can also pass a dummy value for the purposes of just getting it to compile. But okay,
Yeah.
now let's go to the elephant in the room. What is
Okay.
the need for the label? Yeah.
Okay, because let's go from the beginning.
Okay.
What we are trying to do is the following. I'm matching a sum type, right?
Yeah.
And the sum type has a few patterns, right? Like the variable and the wildcard, right?
Yeah.
But it also has the sum pattern, right?
Yeah.
How do we know if one of the sum patterns are satisfied in the sense of can I add the left to the matched ones? How do I know that? How can I know if I can add or not to the already matched ones?
Um, how do I know that the left is already matched? Because we want to save that, right? To check for reachability, I guess.
No, that's the why. Wait, that's the why Wait, what was my question?
How do we know
Oh,
that the
okay, yeah. You
left?
said that why we want,
Yeah,
but how we do that? That's my.
yeah. So the first question that I would have about that question would be something along the lines of, what is the condition in which? Oh, I guess it's just I'm just rephrasing
It
your question.
depends on the pattern, yeah.
So how do we know that you can add the left to the?
Matched list,
That
right?
doesn't answer my question because my question is why do we need the label, right?
No, no, yeah, I will go there.
Okay. But your question is great. So how do we know that we can put the left on the reachable case, on the already previous patterns, I guess? Um,
You can make a parallel on how do we know that with integer and other data types.
well, we know based on the satisfaction factor, right?
Uh,
If we are satisfied with the thing, we add
no,
that
no,
to the
no, no,
list.
no, no. Let me rephrase it for integers.
Yeah, okay,
Um,
go.
I'm in an iteration in which I have a pattern of an integer 1, right?
Yeah.
How do I know that I should add that to the list of preview patterns for the next iteration? How do I know?
If it's not already there.
Yes, yes, yes. Perfect.
Yeah.
Uh, because it's doing it's doing progress, right? The thing I said, like, then you know you're adding, right? Then you are
Yeah.
doing progress.
Yeah.
But now to the sum case. How do I know that I can add the left constructor there? How do I know that, okay, I matched the left. If any left comes into the next iteration, that's a warning because I already matched that.
I don't know if that's a warning, but that's definitely something to be
Like
aware
that's
of.
the warning of unreachable because I already exhausted all the possibility of left, right?
Not necessarily.
No, 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 no. When I add to the list of previews matched, it's because I exhausted. Like I'm telling you. My question is, how do we know when to
No, no, no,
add,
wait.
right?
But I need to go back. I need to backtrack because I don't think I agree with the first statement. You are saying to me that the fact that we are adding to the previous patterns means that we already exhaustively checked that. Is that what you're saying?
Yeah. For example, in the case of the integer, right?
Yeah. In the case
When
that
I add,
we don't do that with the integer, by the way.
no, 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 we do. It's just in a different sense. That's the key point. Uh, so we add the pattern integer one into the list, right? We are saying the following: we already exhausted all the ones. If we get another one, that's a problem too. You see what I mean now?
Okay, so if you see the same left as the one that we already have in our bag, that's an unreachable case.
Yes, and that's like, let's suppose that's set in stone, right? Now, what I want to know is how do you know when to add in the bag?
Um, like let's go back to the ideal way with the fold, right? You only add to the bag after everything is fine, right?
Yes.
So the guard has a boolean and stuff.
But ignore guards. Let's say they don't exist, right?
Yeah.
Because,
Okay, so in the case that you checked everything and everything is okay, that's when you add to the bag.
yeah, like it's
But
not
it,
of the wrong
yeah, but
type, it's not already in the bag, right?
yeah, it's not already in the bag, and it's not the wrong type. Those are the two things that we need to take care of. Yeah,
And
I
then
think it's the same here.
and
Checking,
then we can just add into the bag. Is that what you're saying?
yeah.
But wouldn't that cause a problem?
What is the
Like,
problem?
for example, let's suppose I have the maybe int, okay? I have the maybe int.
Hmm.
And then I do the following pattern. I do a just one.
Yeah,
That's my first pattern. Like so far so good, right?
Yeah.
But what if I do just two, but you added the just on the bag on the first pattern?
No, but you're not gonna add only the name just. You're gonna add the entire thing. You're gonna add the pattern as a whole.
Hmm.
So the pattern, the p sum type pat, the sum type pattern, it's composed out of a name and a list of patterns. So that just one would be added to the bag with the just name, but you would have another list there. And because I'm guessing we are just deriving the equality, and in this case it works perfectly because it's exactly what we want. So it will say, oh, is this in the bag? No, because what I have in my bag is just with another list there saying that I have the pattern 1.
Yeah, okay, okay. Your example is it's so fucking good, Lemos. So fucking good. Uh, because first of all, it's correct for that case, but it's exactly the thing that is a limitation. Because what the reasoning that you said doesn't work for the some cases. Because since they can be nested, they can be infinite.
Oh,
Like,
but they always can.
but I mean, how can I say that, dude?
I don't know about infinite in terms of the language because, like,
No, no,
we're not
not.
gonna parse that, but okay.
Oh, yeah, yeah, not what I mean. How can I say that, dude? It's because, for example, let's suppose the internal, all right, the internal pattern is also a OR, right?
What do you mean by a or? We don't have or types.
Well, not
Or
OR, like
patterns.
a sum, I mean, sum.
Okay.
The internal is also a sum, right?
Yeah, okay, so you have a just of a just. What's the problem?
How are the things that you are accumulating?
We just pick the pattern and put into a list, dude. Like, I understand that it can be infinite. Yeah, it can, but it will never be because the parser will not allow that
Yeah,
to happen.
yeah, yeah. I'm not talking in that sense. Yeah, and maybe I'm using the wrong word. Maybe it's not regarding being infinite. The problem it's regarding being nested.
No, but I don't think the problem is being nested because the equality will check all the list as well. So if you have a just of a just of a just of a just of a 1, that's fine.
With this,
Or like suppose that you have 3 justs, right? So you're gonna have
okay, sorry. It's because I remember the case. How do you know when you're exhausted? All the sum type that I'm checking. If you are doing like this nested way of accumulating in that list.
Okay, so the way that you know that you are exhausted is if you check
That no, that I'm satisfied actually. Sorry.
that you are satisfied. Oh yeah, but satisfied in the sense of being exhaustive, I guess.
Yeah, but like it's easier to not get from, right?
Yeah, okay. So you are satisfied. Mm, what I would be the case with only one? Let's go with the base case first. So if you have a left one pattern matched in your thing, how is the condition to say that you are satisfied or not?
Wait, right? What? Can you repeat?
Yeah, let's go back. Instead of doing the nested one, I want to try to first answer the same question for the simple ones.
Oh,
So
so
let's,
the just one, right?
yeah, the just one. How do you know that that's satisfied for you?
The just?
Yeah.
Yeah, yeah. That gives the answer of the question I asked.
Oh, you don't,
When
right? You cannot be satisfied if you have integers because infiniters are infinite primitives, right?
well, you can like a variable satisfy the integer, but that was not your question.
No, no, no. That is my question. Because
No, you said
that's
when
part
do
of
we
my
sat?
question. That's part of my question. That's
Okay.
actually part of the answer because I think I know. So if you have nested, because you're gonna call recursively later, if the entire thing is not exhaustive, like let's in that case of the just one, let's go with the just one, right?
Okay.
So the just one, it will call the function again with the one inside, right?
Okay.
that will never be satisfied, right? Then the entire thing will blow unsatisfied.
Perfect.
Sorry?
Perfect. It's because I'm like getting some stuff here. Go on.
Yeah, so if you have nested, the recursion will actually make sure that every single component of the nested part is actually exhaustive proof. And if any one of them is not, the entire thing will blow saying that is not.
I think I got your solution. Yeah, so like
Yeah, for
to
me the recursion already does that, but go on.
yeah to give like my solution, and then you can see if like there is some problem there or is like something equivalent. My answer would be, how do you know, like, okay, like from the top down, right? How do you know when the sun type was satisfied? Well, when either you use the variable, right?
Yeah.
Or you already used all the, how can I say?
Wildcard, variable, and psum type, right? Those are the cases that you can match the
Yeah,
sum type.
or you use like all the constructors that your type has, right? In the sense of, okay, I put the just on the sats on this already matched bag. I put uh, the nothing there, like saying like both are exhausted, right? Like
Yeah.
in a sense different than yours.
Yeah.
If that's the case, then I can say like the sum it's satisfied, right?
Yeah, but
Uh,
there's another
now,
internal.
yeah, now the internal case. How do I know when the just it's satisfied, right?
Yeah.
Yeah, that's the main question. My answer is when all the internal patterns of the just are also satisfied.
Yeah, but there's some. Well, I don't know. Probably you were already aware, but I just got aware, like that. Every single moment that you have a nesting, you have another bag, right? So like in the recursion, this is also gonna be done by the
Yeah,
recursion
but
itself.
that's yeah,
But
but in my
so the
case,
bags are
that's
different actually.
inside. Yeah, in my case, the recursive call will
We'll
have
do
that
that
back.
exactly. Every
In
single.
yours, you have to
Mhm.
carry up, right?
Yeah. No. Wait. You don't have to carry that up, right? Well, for my
You
solution, the way
do.
that I said, you do. But that's gonna like when you call recursively in the just one example. When you call that recursively again, let's suppose instead of a one you have another just. The recursive call will already create a new bag for this smaller scope. Because
Yeah.
yeah, let me explain. So do you agree that look at for instance when we are doing the boolean, right? When we do the boolean and we do the integers as well, we have a fold here, right? This is the
Okay.
bag. This empty list is the bag, right? And I don't know if that's gonna happen, but my assumption is that we're gonna have to add a fold in here at some point, exactly as we're doing here. And creates the bag. But if you don't, if you let's suppose that I'm wrong, we're not gonna use a fold whatsoever.
Yeah, we will for sure.
But let's suppose that you don't. Then you are correct. You need to accumulate the bag. Yeah, like you need to carry all the bags inside the bigger bag, I guess.
But you do that, like even with the food in our case. Because take a look. You are gathering the things that would match it on the internal ones.
Yeah.
Like, and that was from the internal recursive call. But then you got out and you pass that to the next iteration. So your next iteration has like patterns, internal ones, right? So
Mhm.
you are like going up and putting the bag on the bag.
Okay, but anyway, so you said you have a solution. So
Yeah. So my answer is, okay, how do we know when they just
when
it's
everything inside
exhausted,
is also
right?
exhaustive.
Yes. So that's why we are doing the thing of collecting patterns to check if the just is exhausted, right?
Yeah.
That's what we are doing. Uh,
Oh, dude.
yeah,
Ah.
yeah, exactly, exactly.
Okay.
Whew.
Okay. So going back to Earth.
Oh yeah.
Okay. I'm very surprised that I understood what happened there, but okay. So let's go back to here. So we have a list of types, and then we have a list of patterns, and they are already transposed. So the firsts are grouped together, the seconds are grouped together, and so on and so forth, right?
Yes, we hope so.
We hope. Okay. So my understanding is that now we need to add the nothing as the guard here for now, and we also need to add the dumb expression, and then we just unzip the tuple, like we undo the tuple, and we call check exhaustiveness again.
Wait, the unzip that you mean it's the zip, right?
No, it is to unzip. This is already a tuple, right? See with the parentheses?
Yeah. Yeah, but what I guess you want is
Oh,
you
to
are
zip each
mapping the
type.
external
Yeah, yeah,
list.
yeah, 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 yeah. Okay, so yeah, oh, sorry. You are totally correct. You are totally
Uh,
correct.
yeah, so when do we add? Wait, we are going to add what? I forgot. Oh,
W-
okay, the thing to check the check exhaustiveness, right?
Yeah,
So dude, that's okay. That's map, right? Like
that's map.
external one. The
Yeah,
internal one will zip and add this thing that like the false guard, right?
yeah. Okay, so now it's totally wrong, which is cool.
I think that is a cricket here.
There is what?
Cricket.
I have no idea what is that.
Grilo.
Oh, okay. Okay, so we want to map this entire thing. So let's do that. So more something map
Oh,
zip something.
come on.
Okay, so it's not zip. It's not map. It's not map zip definitely.
Mm.
So we are doing something wrong.
Oh, because you have to extract the things, right?
What do you mean by extract the things?
Like, how can I say? Like they are inside the tuple, right? We have to like uncurry.
Uncurry, yeah. So we uncurry that. Maybe it's curry actually. No. Okay, so I have no idea what we are
We are
doing
doing
here.
something very wrong.
Yeah, we're doing something very wrong. Okay, so the uncurry picks a list of tuples. Oh
Wait,
no, it needs to
what?
pick a function to combine them after, so it's zip here.
Oh, okay.
Okay, so what's the type of that? Okay, so now it's this.
Wait. What the fuck is that?
Okay, so let me show you the difference. You see it here?
Uh-huh.
So you have a list of tuples in which each tuple is a some sort of a list, right?
Um,
But now we have a list of lists of tuples. Yeah, I think this is exactly what we want actually.
nah, I guess we have something off there.
We have a
Yeah,
lists of lists. We have lists of
we
lists, right? And then each internal list contains a tuple with a type and a list of patterns. That's what we
dude,
have.
I almost sure we have something off there.
I don't think we have something
And maybe it's just a flatten, like the solution, maybe.
Maybe it's just a
Yeah,
flatten.
because what we want is what I typed, right? A list of tuples of type and a list of patterns. But we have one list more, right? Let's see
Yeah,
why.
but I don't know if that make just calling it concat makes sense. Uh,
Yeah, that's the thing. Let's see why we have it, and depending on the reason, flattens the solution.
okay, I don't know the episode 3 of the Star Wars, but it needs to have something list in the title today. We have so many lists, dude. Oh, look at this.
But let's try to get this part to like end the thing. Uh, So okay, let's see the something again.
Oh, the something is already over there.
Oh, okay. So that's so much horrendous and heavy. Ah, whew.
Holy
Yeah.
crap, dude.
So let's see. That's a list of tuples.
Yeah.
Uh, yeah. So what we want is when okay, if we zip those, the result will be a list. My head is just frying here. Ugh, holy shit.
Okay, I can help you with that. So we're gonna pick each list. Ignore this internal list of patterns here. Okay, imagine that this is a list of
No, no,
types, a
no,
list of
wait.
whatever.
We need to know first what this means, right?
Yeah.
Because even though we already said that like 1,000 times, I guess, dude, I always need to check again what that means, right?
Yeah, that's totally
So
fair.
let's
That's
see.
more than fair.
The list of types is the following. Oh, yeah. I guess it makes sense the thing because we were separating them by constructors, right?
Yeah.
But oh, wait, we didn't solve the problem of the label. That's why that's a problem. Dude,
No,
you
but the
cannot
pro
just flatten.
you cannot just flatten. Okay.
Yeah, because the label. But before that, we need to get the label, right?
Yeah. Can you remind me again why the heck we need that?
Yeah. Oh fuck! That's why we were discussing
Yeah, dude.
the crazy thing. So, okay. So how do you know that just is satisfied when the internal ones are satisfied, right?
Yeah. What's the problem?
That when the internal ones are satisfied, it's a recursive call, right?
Yeah.
Then the result of the recursive call will say to you if it's satisfied or not, right?
Yeah.
Then that's the thing. Once I know it's satisfied, then I can store that somewhere.
No, but we didn't get there, dude.
No, yeah, sure. But when I know that, I need to know if it was talking about the left or the right. You see?
Oh. After we acquire the result of the recursive part, we need to say, okay, this is there, but
Now I can add
what
the
was this
left in the
from again?
bag.
Like the question.
Exactly. Exactly. Oh, dude.
Okay,
And
so my suggestion as a grug as I am is to just add it here.
by the way, now we might know a reason why the language don't implement pattern matching. At least the typed ones, because only the evaluation is pretty simple, right? Dude, it's how to implement that, like for sure.
Maybe we're dumb. So that's also always a possibility. So
It is, but I would say it's much lower in this case.
I don't know, man. You have your makers of language there in your Discord. Ask them what do they think
No,
about it.
of course, compared to them, yeah, but
Holy moly, dude. Yeah, but I think we solved the problem. We just need to fix this map now. Alright.
wait, you need the label.
Yeah, I added the label already.
Oh, so let's see. Okay. So what is something now?
Something is this.
So let's see. So you have like a list.
How the heck that
Okay.
worked?
Huh?
I'm very surprised that the second is working on a triplet, dude. What the fuck? Okay, go. Do you understand that?
Yeah. Now I'm asking, is there a high class? Like, oh, hair second, right? Can't map the second, the name of the time. Dude, indeed. Oh,
How
but
does it
well,
know? I think it's because in the triplet the second is always the last one, maybe in like any tuples.
it doesn't matter. Like if you have different types and you are using the same second, that should be type class involved, right?
No, no, no. But that's what I said. Maybe all the implementations of all the tuples map like implement the second as the last one. Because if
That's
that's
the
the case,
last one.
this makes sense. Yeah, because let's look here.
That would make no sense. Second not equals last.
No, I agree that the meaning will be terrible, but wait.
Oh, is it because all of them implement this defunctor shit? And that
Uh,
implements the second?
I guess.
We can take a look on the second implementation, right?
Yeah. But the LSP saying it's correct, and for some random reason, I just want to believe it for now. So we have the name left, we have the types, and then we have a lists of patterns. That
Yeah,
sounds correct.
so let's see. So we have a list, right? And it's a list of different constructors with other stuff, right?
Yeah.
Basically. What is the other stuff? It is the types it carries, right?
Yeah.
And then the list of all the firsts, the list of all the seconds, that in a list, right?
Yeah.
So, yeah.
Okay, now we just need to do label types
Yeah, now the
patterns.
query
Yeah, the
probably.
query unfortunately is not gonna work.
If we change the order of the text to be the last one, I guess it works still, but I'm not sure. Oh,
Okay,
wait, no,
now
it doesn't work.
now it is this.
Holy shit. Holy shit.
Dude, we are just like almost 2 hours in, and like we changed 3 lines of code.
Dude. Dude. Like, I have to say, I never saw something like this. Besides the ones that you have like a bug, it's like one line or one character. But in that case, I will not count because it's not a problem that you progress. You either totally don't know what it is or you solved already, right? But in
Mhm.
our case, we are like progressing, so I
Yeah.
never saw that.
Yeah, okay, but now, dude, we have something important. We have the type that you typed there. You see?
Yeah, uh, like together we
Yeah, we have together
we
in the
know
tuple
how it's the constructor, right?
the type. Now we have the name of the constructor. We have the type there in the tuple with a list of patterns. So that's fine. Now,
Yeah,
now,
I think that's perfect. The
okay, now
things
we
that we
need to
have.
map the thing again because we need to add the dumb stuff to it, I guess. Um,
No, you can already just do that already, right?
what do you mean by just do that? You mean in here? Yeah, I can do that.
Maybe we don't.
No, but
Can't we just every?
we
Oh,
can do that.
no. Maybe we don't want to do that in the sense of what is that? You're making something again. Yeah. That's probably something that we don't want to do, Lemos.
What do you mean,
Uh,
dude?
yeah.
No.
Why not unit, dude? Are you a psychopath?
Okay, so what's the type of that now?
Uh,
Okay. Oh no, that's not okay. Oh
Lambs,
shit.
Lambs. Why don't we just fix that on the calls that we are going to do with the check exhaustiveness instead of putting inside our data structure?
No, that's fair. So you're saying to do that, so we probably have an extra there.
Like
Okay.
eventually we will call check exhaustiveness and it will
Yeah,
have the dummy
eventually.
stuff by
Eventually.
default. Yeah. With eventually I mean just after that. Um,
Yeah,
dude.
okay. Okay, but okay. Uh Oh wait. Wait. Dude,
Oh
we don't
no.
need we don't need I don't think we need this. You know
Need
why?
one. What? What do we need? What don't we? Why don't we need?
Oh no 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 wait we need because we need them to be together because this for m is already doing that. Like this is the name of a constructor. This.
Oh, oh, okay, yeah, yeah, but the foreign is something that we like haven't done yet, right? In the
Yeah.
sense of we are not working with that yet.
Okay, so we're gonna do a for m with more something. It's not gonna be a for m this because we want the result of that. So it's gonna be this. Let me just.
Wait, let's first think. What do we want as the result of that?
We want to call check exhaustiveness, right? So we have a list, and then in each list we have a label. So this is the constructor name.
Oh, yeah, we have like the constructor and if it's satisfied or not, right?
Um, no wait.
A list of a tuple being
Yeah yeah yeah
having
yeah 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 yeah. Yeah. Yes, that's what we're gonna
like,
have. But now let me just take a moment here. So we're gonna have this thing that I'm gonna call to to check. That's what I'm gonna call it now.
dude. I guess we finally reached the point where we might want to change the satisfied and unsatisfied data type. Yeah. Because
No, we
take
don't
a
need that.
look.
We don't need that.
I think we do.
I don't think we do. You know why? You want to know
Hmm.
why?
What?
Because we can use the bind inside this lambda.
Wait, but use for what? You don't know what I'm about to say.
No, because I thought that you were about to say to add a label to the satisfied stuff.
The label should satisfy.
Yeah, because then the satisfied will also like the satisfaction will also throw us the name of the thing.
The name of what?
This name.
That's not. Yeah, no, we don't need that. We have that, right? So why?
I don't wait. Okay,
I'm
just
not
say
really sure
what
if that.
just say what
Okay.
you were about to say then.
Yeah. Because we are calling on the internals. Okay.
Mm-hmm.
Uh, is that a problem, dude?
Okay, let me just finish this and then we can
Okay.
discuss whatever. So my understanding. Holy fuck! Wait, wait. We have this is a list of a type and a pattern. What we want to do is to call mapm using check exhaustiveness, but we're gonna have to unwrap the tuple and crap. And this is to check. Yeah. Then this will be a tuple in which the first position will be a type and the second position will be the patterns. Yeah. Then we're gonna call check exhaustiveness with that type, but the we're gonna have to map the patterns to have the extra stuff. So we're gonna pick each pattern and transform it to a triplet with the non and e literal el unit. Yes. Yes.
Integer one. Dude.
Then and we're gonna pick whatever
We need
is
to
coming out
check
of
if all
there.
of them are satisfied, right?
Yeah, but no, but that's gonna be totally fine. Constructor R. Yes. What is the type of that? That is a list of tuples.
It's unexpected.
No, that is expected. Check exhaustiveness returns unit, so that's expected. Um,
I mean, not as what we want, but yeah.
okay, we don't need the unit stuff because we just need the thing to short circuit for us. So this is actually this. Yeah. Now this is just list of constructors that worked.
Oh. Wait.
Holy bananas, dude.
That's great. I was thinking like the following. Oh, we just return the name and if it was satisfied or not. But we can just return the name of the ones that were satisfied, right? So yeah, that's a good idea.
Okay, so let me
Unless
let's
we
try.
want to know the ones that were not satisfied. Oh yeah, maybe let's go for the same. Oh dude.
Okay, so let me try to explain what I'm doing here. So let me just see the type of this thing because I am very oh no, it is correct. This the function that we are doing things, it's monadic, so it's correct. Okay, so I am this list here, which is a list of tuples, in which we have the first position is the constructor, and the other things are the things that we want to call check exhaustiveness on, right?
Why are you using the for?
I'm
Yeah.
using the for because the function that I want to for, which is this A to MB, the M is a monad.
No, no, I mean, why don't use the map? Because we don't need accumulators and shit,
No, but the for
right?
doesn't have an accumulator.
What is the difference from the for and the map?
The for,
Oh, okay. Okay, the unit thing. It ignores, right? The thing.
no, no, no. The what ignores is this bind.
Wait, isn't the for?
No, the for is to do iteration throughout this list here, right?
And why not a map? What
I
is the difference
think
between the
I
map and the for?
think the difference is that the map. I'm actually not certain. What's the type of this? Oh, it's just
And
the
then this
order.
is. Oh shit.
It's just the order. It's just the order.
Oh shit.
So,
Okay.
but let's try to put less burden on whatever is crazy enough to read this.
Yeah, that
So
makes
let's
a lot
put
of
more
sense.
something there. These names are great. Something and more something.
Yeah, it's better than full and bar, but not great, right?
Okay, so we are grabbing the constructor and we are grabbing the things that we want to apply to the check exhaustiveness, and we are doing an internal map to this list this time. Basically,
Use the check exhaustiveness on that list. Right?
yeah, that's actually the only reason we have this external one is because we want to ignore the output of the unit and return the constructor. If we didn't have this, it would be only one map m. But anyway, so then you pick this list, you're gonna
No,
map
no,
m.
no. We need two maps anyway.
I don't think so. I think if we didn't have
Because
this thing here, these would not have text. This would be just a list of these.
oh, okay, yeah. You are saying if we don't have constructors and we
Yes.
could flatten later, right?
Yeah.
Okay.
So you're gonna call check exhaustiveness in here. So that's another map m. This is a type, and this is a list of patterns. But we need to change the list of patterns because the check exhaustiveness only accept a list of triplets. So we map that again, the PS, which is patterns, to this. Then we just call check exhaustiveness, which is going to return a result of a unit. But we ignore.
That is a huge bug here, dude. That
Go.
is a huge bug.
Okay, go, go, go,
No,
go.
no, a literal bug, like here on my ops.
Oh.
I'm a bit scared, but let's go.
Okay. So then we're gonna ignore the unit, which is why this bind doesn't have the equal, and we're gonna just return the name if it works.
Wait, dude, I'm a bit sweaty. I'm trying to defend myself.
Okay.
Okay. Okay. The result of the check exhaustiveness is
The result of check exhaustiveness is a result of unit.
okay. 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 That's okay.
So, so
And then we ignore that and return the constructor, right?
yeah.
That. Hmm? There's something wrong with that, right?
What do you mean?
I guess there is something wrong with that. Because that will generate a list of constructors, like constructor list of constructors, right?
Yeah, this will return a list of constructors.
Wait, wait. Ah,
Well, list of constructors names, I guess.
I'm missing something.
Okay,
Uh,
let me go again then. We
the to check, it's a list of stuff that we want to call the check exhaustiveness on, right?
yes,
And the result that we want by that is to know if the constructor on the left of that tuple was
is
okay or not, right? Like was satisfied or not,
yeah,
right?
yeah.
Yeah, but if you are transforming the to check in a list of constructors, what are you doing then to correct that?
Okay, so let me explain. So this will execute using the to check stuff, right? So this is
Okay.
yeah. So
What is
if
the result of that?
the result of that check exhaustiveness is always a result of a unit. Is that okay?
Wait, no, wait. The result of the map. I want to know the
Oh,
result of the map.
this
Yeah.
the result of that. Oh, it's gonna be terrible. Yeah, it's gonna be a result of a list of unit.
Result.
Yeah, ignore this except it text. Read this as a result. Result
Okay.
of list of unit. Yeah.
Okay. Something that we can totally ignore, right?
Yeah, so that's what I'm doing with this bind here.
Okay, that's ignoring the whole map, right?
That no, that is ignore. That is like it is ignoring the result of the map.
Oh, what I mean is the result of the whole map and stuff, right?
Yeah, and the suggestion that is actually showing us here is actually useful. So I'm gonna add it there. So that yeah. Okay.
Yeah. Okay, then you are returning the constructor, right?
Yeah, so the constructor that provided the list of units, and none of again, if any of these things crash, everything will blow up again.
Wait, that is
So
something really
if this
strange.
mapm blows because one of the check exhaustiveness didn't work, everything will blow.
Wait. Yeah, but wait. Yeah, that's just like infra. Uh, so that tuple of constructor and to check is turned into a list of the same constructor.
Yes.
So how don't you get the list of text? How?
Wait.
How do you do that?
No. Wait. I think you're confused. The list, the internal list is only applied to the pattern, right? Because we have a list of tuples,
No,
which
wait. No, we don't need to talk about the specifics. What I want to know is this current element of the map, it's a tuple, right?
the current element, you mean the T and the PS?
No, constructor and to check.
Oh,
That's a
this
tuple.
true. Okay,
Yeah.
because there are two maps here.
Oh, okay, yeah, but this outer one,
Yeah.
like that's the element, right? The element will suffer a transformation. What is being the result of this transformation right now?
Do you mean the transformation that being done by the mapm underscore?
You have an arrow on the left side of the view. What is the result of that expression on the right side of the arrow?
This arrow,
No. The the first arrow.
this arrow.
Yes.
The
At the right side, have an
okay,
expression.
so the result of this is a text.
Oh, it's not a list of text.
Yeah, the list of text is the final result of the outer map.
Oh, okay. Now I see. You ignore everything. Oh, I see. You are not ignoring inside and
Not
returning
no,
to your
I'm ignoring the
constructor
entire
there.
list of
I see.
units. I'm ignoring the entire
I
list of
see.
units. Yeah.
Okay, now I got it.
Yeah. So then this thing is a list of text, which is the constructor names that worked.
Wait. Good. Yeah, we might have.
I also think we have a problem, and I can already see. Just tell me.
Okay. Yeah, the problem I'm thinking about
I think we need to
is
save, dude. We need to save the patterns, right? We need to save this.
yeah, that's not what I was thinking about. Can you say your first?
Yeah. So remember that the strategy is that we need to add to the bag now
Mm-hmm.
because it worked. The fact that we got out of this map ham means that it worked. What that means is that we need to save to the bag. And because we need to save to the bag, that means that this is part of the whole sum type that we want to save in the bag.
Yeah, but the only thing we want to say in the bag is the following. Oh, we exhausted the left, so we just need that.
No, but we didn't exhaust the left. We
No,
exhaustive checkly just one or just of a one.
no, no, wait.
If you have
No,
other
no.
lefts, if you have other lefts down there, they are not equal to the left that you have on your bag.
No, dude. You see the constructor. Okay, see the tab of constructor and to check.
Yeah.
The constructor there, it's saying like what constructor is referring to,
Yeah, this
right?
is left.
Yeah.
And this
So
is the
the
other
to
lefts
check.
inside.
Yeah, this is all the like lefts at the same time, right? All the patterns
Oh,
that
dude,
were
this.
aggregated to the left.
Wait. I think I am confused. I think you're right. Because we are checking all the left at the same time.
Yes.
Oh, I'm dumb. Okay. Okay, we are
Uh,
checking all the left at the same time. So you're totally correct. We can save only the constructor name. But I don't know how we're gonna do that.
because
Because
it's a pattern type.
not because it's a pattern type, but because we want our bag to also be able to have wildcards and names. So how the heck are we gonna do
Uh,
that?
Wait, what? We want to what?
Yeah, the bag needs to be able to accumulate the wildcard and the p variable as well. Remember?
Wait, what is the p variable?
It's a pattern.
What's the oh, the pattern variable?
Yeah.
Yeah, we don't. We actually don't, Leonard.
That I don't understand then.
Yes. The only things we need to keep track there are the things that are doing the progress, right? The thing we talked about. Because when you have something like a variable that's like done, like you know you are satisfied, then you don't need to add that into the bag.
Wait, repeat the last part?
Yeah. You don't need to add variable to the bag because when you get variable into your iterations, you are done. You know you are satisfied already, like for sure.
No, but what
Because
if what if wait, wait. Wait, I am confused. So let's say for a moment that the value that we are trying to pattern match is a T-algebraic type. And let's say that inside this list of patterns, one of them are lefts, other ones are rights, and some of them are names, and some of them are wildcards. Okay? So this piece of code, as far as I can tell, is only checking for the.
yes, it's totally ignoring everything that is not the constructors.
Yes, yes, that's wrong, right?
Yes, that's right.
Okay, so then how can we fix that?
Wait, we are not there yet. But we are almost there. But
Okay, but
man,
then no, my,
it's
my
already
question
nine.
remains. No, but we started later. We have only still 3 minutes, dude.
Okay.
So my question for you is, if we add left to the bag, right? Because we checked all the lefts, correct? Um,
Okay.
how we gonna be able to save that you are already have in your bag the. Oh wait, but you don't have to save in the bag because you are satisfied.
That's exactly what I said.
Yeah, so I'm just dumb.
No, wait. You still have the problem that you talked about, but this that we were saying about saving the deck has nothing to do with it.
Yes. Yes. So if you have any of those that you're gonna have to implement in the next session, you don't have to save in the bag. So that the bag can only be at things with the um,
There are not catch-all cases, right?
they are not catch-all cases. Wait, wait, dude, do we need to save these names in a bag? Because aren't we done?
No. No, no,
No.
no. No.
Okay.
Because that is for us to see, oh, let's check the internals and blah, 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 blah. But again, we are not checking the other stuff like the variables and such, right?
Oh, so you're gonna call check your exhaustiveness again here then?
Yeah, now we need to see the way of the order of stuff and blah, blah, blah. Now we are going to come with some solution that might not exist, right? Might not be
Okay,
possible.
so my first instinct is to try to reverse this filter because
So
this
scared with the word reverse there,
yeah,
dude.
because this filter is only filtering the ones that are p-sum types. Do you agree?
What do you mean by reverse it?
No, no, no. Maybe I used the wrong word for it. Just
Oh, not reversing a list, like
no,
use the previous
no,
version before filter, right? That's what you
no, no,
mean.
no. I want to do the intersection actually.
What?
Not intersection. Yeah, it is
What?
intersection. No, it is. There is a name in set theory for that, but I don't know. I want to pick all the ones that were filtered here and do minus with the original one, right? Because then we're gonna
You
have
want the difference.
the difference. Yes, I want the difference of the filtered ones with the. Oh, that's wrong. Holy Jesus, dude.
Okay, the first thing that I'm thinking, and it's probably also wrong, is let's go through it again, but now with the information that we got from the result. Now considering the other variable and stuff.
Yeah, but there's a problem, dude. We are not tackling the sum types that do not have like lefts and rights. If you have a just there, we need to take that care of that as well.
Oh, wait, what?
Yeah, if you have like if this is a neither,
No, wait. The is pattern type already like handles that. We check the constructor name, right?
um, yes. Okay, okay, good.
That's defined, right?
That is there. That
That's a
is
good
there.
function, dude. That's
That
a
is a
good
good
function.
function. And I'm making even better.
Wait, what the fuck are you doing? Oh, okay, the syntax.
Yeah. Okay, so okay, so we already checked for p sum types. Yeah, so it's just the difference then, isn't it?
I don't know what you mean.
Yeah, we want
Can
to
you
have
say
all
again what
the.
is the difference?
Yeah, we want to know all the ones. We want to
Okay.
exclude everyone that is a sum type.
Exclude from which list?
This one that I'm hovering right now.
Okay. All the ones that we got as the result of
No, no, no.
filter?
We want to remove all the ones that are sum types from the patterns.
Oh, like all there are sometimes.
All yeah, because the ones that we care we already handled, and the ones that are wrong we already handled as well.
Okay, so you are literally only getting the variable and wildcard, okay?
And the literals and all the other crap.
No, you don't have that.
No, we do. Didn't
No,
check
we
it yet.
no, we don't. Like the is pattern type. Oh, oh,
Yeah, you saw now.
oh.
Okay.
Okay, because list is like like invalid, right?
Yeah, it can be wrong.
Wait. Oh man, my head is. But I suck.
Dude, this project is awesome. I love it. I totally love this.
Wait. Let's.
Yeah.
Wait, but but wait. If you are doing that into the them branch, we know there are no wrongs there. We can
No, but
just
I
use list.
but that only applies if you are doing it in the them branch. I was thinking about doing outside of the if.
Oh, outside of the if.
Like I
Why?
want this to be exclusive to some types or something along those lines because
That
this
doesn't
is
explain something.
uh
Wait. 1 second, dude.
what?
Go to the result line. Go to the first map of that line. Like just map, not map M.
Oh, the first map. This
Yeah, what is that comma there?
this is a Haskell extension to use incomplete use the constructor of the tuple as to the map. So I'm creating a triplet by making each element of this list to go to the first position.
Oh, that's like a hole, right? Like
Yeah,
a placeholder.
yeah.
Oh, that's nice.
Instead of making a lambda.
Okay, so why outside of the then?
Because I wanted this whole block of if then else to be exclusive to some types patterns. I don't want to mess them up. I,
If, okay, okay. So,
so that means
well, they already are, right? Because they are inside the.
no, they already are because we only tackled the some type.
No, 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 no. Line 8 up. Like you are matching the algebraic.
No.
All
That's
the
fine.
code on that
No,
function
no,
will
no. That
be.
no, that's not what I meant then. What I'm saying is that I want to make this piece of code exclusive to p some type. That's what I mean.
Oh, I see, I see. Okay.
Then this list can be whatever if you're tackling it outside of the if. Which
This
means,
list.
yeah,
Okay.
which means that we can have literals, we can have whatever
Okay, but
there.
now I can ask the reason why.
Why what?
Why do you want this block on the then to be handling all the P patterns, like the sum patterns?
My first instinct is that I want to abstract this out.
To
Yeah, I
use
want
var.
to not be always here, like making it harder
Isn't
to
that
read and
totally
stuff.
against what we are doing? Like trying to abstract something without knowing?
No, kind of, because we already quote unquote finish the p-sum type.
No, 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 but that's only a piece of the problem you're solving. How you will
Oh,
abstract that
okay, so
out?
we want to make it here and then later we abstract it out?
Yeah, I would say that's wiser.
Okay. So then you want to do it inside the if then.
Yeah, like we know things are validated.
Okay. Um, um,
But okay, let's say you have all the wild cards there. Now what?
yeah, you have the wildcards and the variables.
Well,
Uh,
eh,
now you do the fold. Now you do this.
yeah, that doesn't work.
No, it does. It totally does.
That's it.
Totally does, dude.
Why doesn't? Because you have a list of the sum patterns, you have a list of variables and wildcards,
Hmm.
but if they are not together and in the wrong and in the correct order, you don't have enough information to do this stuff properly
No, but I'm not gonna pass
because
this
the
list.
order.
We're gonna have to filter this list first.
No, 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 wait. I'm assuming you already have, like, okay, I'm assuming you already have a list derived from this one that is just variables and wildcards, right?
Yeah.
And you have the, oh, and yeah, you don't have the patterns and branches that are the, oh, that's interesting.
I don't know
But,
what
and
you
you
mean.
have
Go
the
on.
result. You have the result, okay? You have this and the result. What do you want to do with it?
I'm gonna pick the list. I'm gonna pick the list, and I will filter all the psum types.
Oh, I already told you, you have only variables and wildcards.
Yeah.
What you want to do with it? And you have result.
Then I'm gonna do this fold here, in which this thing is result. This empty bag is not empty, and you're gonna say that you are unsatisfied, and then you're gonna do the function only with wildcards, variables, and guards.
Yeah, that's totally doesn't work.
I don't see why. Really don't.
Yeah, yeah. It's easy to show. Uh, so take a look on the following code. We have something like this, and this, this here, and this here, and this here. You see that?
Yeah.
I have a just, variable with just,
Yeah.
wildcard and a just.
Yeah.
So what you are doing is grabbing the stuff completely out of order and then doing the check only on the variables. You see that totally kills the point on knowing when something is unreachable.
No, but we don't care there about that at the moment. We said that 2 hours ago.
What are you checking then?
I'm just checking if.
You're checking nothing.
Oh, because they are always satisfied. No, no, no. I'm checking if they have guards. That's what I'm doing.
What does that do?
That means that if we have a variable, if you have a variable that has a guard, that is not satisfied, right?
No, 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 but wait. That's tricky too. Uh,
Yeah, because you're not checking for unreachability. That's the only thing that I would be checking. Yeah.
but you want to say you are checking the type of the guards and the type of the blocks?
No.
What do you want to check then?
I want to check if each of the remaining patterns, which in this case would be p variables in wildcards,
Okay.
if they all have nothing as they as their stuff, as their guard. Because if they do have a guard, that means that we are not satisfied with that, right?
Yeah. Uh, uh,
But what you said about unreachability, that's totally fair.
the thing. Um, like, dude, like the whole point of what you are doing, like called check exhaustiveness, it's two kinds of check. Wait.
It is. I agree with that.
Yeah, like is the check of either it's unreachable
Yeah.
or it's non-exhaustive, right?
Yeah.
So we wouldn't be doing any of those.
No, we are doing the check exhaustiveness.
Wait, what is that? Is the one if, oh, do we lack things?
Yeah.
Oh, okay.
I
Let's,
totally agree that we would not be checking reachability.
okay, we just want to see if the thing, like, will not, like, drop to the border of the thing, right? It's
Yeah.
someone will always check. That's
We're
what we
gonna
want to
have
know,
we're
right?
gonna have to address the reachability at some point. I have absolutely no idea how you're gonna do that.
Yeah, we have the following. We need to know if result already, like, satisfy everything, right? Because if it does, then we are done, right? We know that everything will match. You agree?
Wait. I don't know if I agree.
For example, if I see that result got all the possible constructors for that type, then I know that will always match, right?
Oh yeah. Yeah.
So that's the only thing we want to know, right? If there is nothing left, we don't care about extra stuff, but we want to know if there is nothing left, right? So then we could also do something fun, like what you said about result. Indeed, we could check first, like before the if. Because if one of the catch-all cases don't have a guard, indeed, the function is done. We don't even. What I want to say about this is you're correct. You're totally correct. If your premise is I only care about I know that something will match. I don't care about extra stuff. I just want to know if the thing will always match. Then sure, that it's a really good implementation. Like depending on the case, you will do only a few computations. But first of all,
Yeah, but the problem is the
dude,
other
yeah.
one.
If you want to check for unreachable, you are done. You just cannot in the way we are doing right now. You just can't.
No, yeah, this implementation is completely changing the
Yeah.
order and stuff or whatever. So
And the other thing,
we're gonna
Lens,
have to do check about that later.
the other thing. Well, I would say the other thing is report error, but if you don't care about unreachable, then you are not reporting.
No, but we care. We don't care about that at the moment, but
No,
we need
no,
to address
yeah,
that.
no. Okay, I'm talking about the moment, right?
Yeah.
Like I'm talking about what are the problems of that implementation. Like I told you it was perfect for like only checking what we want, right?
Yeah.
But it's not possible for checking unreachable.
Yeah.
Then I was about to say, oh, I don't know what's the scenario on the error report, but it's simple. You only have two kind of like errors besides the type errors, right?
Yeah.
You either it's unreachable or non-exhaustive. The non-exhaustive we are already doing, right? So that's just one error. Either it is or not. The unreachable, that would be multiple that we would might care about in which order appear. Well, we don't care about them, so it's
No, no, no.
perfect.
Yeah, but
I'm talking about this moment,
yeah, no, I know, but
like
I
this
think
implementation.
no, but I know, but at the same time, I would say that because we already like, I'm not saying that we did it because we have to test it or whatever, whatever, whatever. But assuming for a moment that we did do it, um, I think we are at the point that we need to think how to re-embed the requirements that we dropped, right?
Yeah, you don't need to worry about that. Like I'm doing a offline implementation, and I have things proper for us, like for real, like with proper report and shit.
I don't know what you mean by that. Like, what do you mean by proper? Like, it seems like you already know the solution. Like, I don't know what you're saying.
Well, no, no. Hold it. What I'm saying is, uh, there are different ways to report the errors as we were talking about, right?
Mm-hmm.
Like different order and stuff. I described you one, right? Like top down, left, right.
Yeah.
Having the premise that's like the optimal way to report errors, I'm going to do a solution that does that, going line by line in a fold.
Oh, so you're making the way everything all together in one single shot.
Yes. And it's not as spaghetti code as one could guess.
It's not as like explosion. It's not explosive.
No, 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 no. It's quite good so far.
Okay, I'm probably gonna disagree with that because I think our accumulators will be horrendous. But
Well,
uh,
so far I literally have two things, and it's a type and a boolean. It will probably have the least of the previous things, but I guess that's the maximum.
well, anyway, if you get that on going, we can change this. Yeah, but that's gonna be so. Man, that's gonna be so sad because you're gonna have to drop this entire thing, I guess. Right?
Well, pretty much.
Yeah, that kind of sucks.
But yeah, but if you see about the problems that we have, like regarding stuff, I guess we can agree that's unfixable, dude.
Unfixable what?
Okay, kind
You
of
having
unfixable.
the reachability check?
Yeah, like if you want to like increment on like caring about more stuff in the next step, what we have there, like it's mostly to trash indeed.
No, so you already thought about it, and you are 100% sure that you cannot re-add reachability here.
Dude, I'm
And
almost sure, but we
I
sure can think
am not
about
sure about that.
because my argument would be the out of order, right? Uh,
Yeah,
because for
but we
it,
have the original list already. It would be inefficient, but we can traverse it a second time. That's not a problem. Like the question that
yeah,
remains is, can we reuse this result to like traverse this list a second
yeah,
time and
that
check
was
for
the first thing.
reachability?
That was the first thing I said, right?
I don't know if it was the first, but I'm just saying
No,
that
no. I said, oh, the first thing I think about would be going to the fold on the list and considering the knowledge of the result.
no,
Uh,
but again, that means that this approach is not going to trash because that means that it is possible to re-add reachability.
but yeah, yeah, maybe that's possible. I was only thinking indeed about the uh, getting the filtered list and the result. Then you have no way to know order and stuff.
Yeah,
But
not
yeah,
yeah.
but yeah, okay, maybe we don't need to trash. I will try to do a quote unquote perfect implementation offline nonetheless, and we can have like reference for some part if we need.
Yeah, but that's pretty much okay for today. So 2 hours and 20 minutes. So bye.